Student, today we are going to discuss about surface chemistry. It is the chemistry which deals with the boundary separating two bulk phases. Is termed as surface chemistry. The boundary is also called the surface or interface. Solid-solid, solid-liquid interfaces are well known. And as gases are completely miscible, they do not form any interfaces. Okay, an interface is only a few molecules thick, but its area is dependent on the particle size of the bulk phases. Okay, there are so many important applications of surface chemistry such as corrosion, electrode process, adsorption, heterogeneous catalysis. Okay, these are the important applications of surface chemistry. Okay, now we stated about adsorption. Okay, student, adsorption. Adsorption, the phenomena of attracting and retaining the molecules of a substance on the surface of a liquid or solid, leading to a higher concentration on the surface in comparison to the bulk, is called the adsorption. I am saying once again, the phenomena of attracting and retaining the molecules of a substance on the surface of a liquid or solid, leading to a higher concentration on the surface in comparison to the bulk, is called the adsorption. Okay, and there are so many examples such as water vapors on the silica gel, hydrogen, oxygen, ammonia on the activated charcoal. Okay, there are so many examples, student. Now, desorption. Desorption means the reverse of adsorption. That is the process of removing and adsorb substances from a surface on which it is adsorbed is called desorption. So desorption is just reverse of adsorption. Okay, and adsorbate, the substance accumulating at the surface of the liquid during adsorption, is called adsorbate. Okay, the substance accumulating at the surface of the solid during adsorption is called adsorbate, and the surface on which adsorption occurs is called adsorbent. Okay, now absorption. Absorption, it is the phenomena in which a substance is uniformly distributed throughout the bulk. Okay, so adsorption means accumulation of substances on the surface of a substance, but absorption, it is a phenomenon in which substance is uniformly distributed throughout the bulk. That is, it is the penetration of the substance through the surface into the bulk of the solid. Okay, such as water vapors are absorbed by the anhydrous calcium chloride. Okay, now sorption. Sorption means sometimes the adsorbate dissolve into adsorbent. Okay, and initially the adsorbate appears on the surface of adsorbent. Okay, and later passes into the body of adsorbent. Okay, so thus adsorption changes into absorption. Such side by side occurrence of adsorption and absorption is called sorption. So we can say that both adsorption and absorption can take place simultaneously also. Okay, and the term sorption is used to describe the both process. Okay, so now types of adsorption. There are mainly two types of adsorption: physical adsorption and chemical adsorption. If the force of attraction between the adsorbate and adsorbent are van der Waals forces, then the adsorption is called the physical adsorption or physisorption. If the force of attraction between the adsorbate and adsorbent are van der Waals forces, this is a weak force, van der Waals force, and then the adsorption is called physical adsorption or physisorption. Okay, and chemical adsorption, if the force of attraction between the particles of adsorbate and adsorbent are almost of the same strength as the chemical bond. Okay, and it is low in case of physical adsorption. Okay, and the adsorption, if the force of attraction between the particles of adsorbate and adsorbent are almost of the same strength as the chemical bond, the adsorption is called chemical adsorption or chemisorption. Okay. Now we can compare the physical features and of physisorption and chemisorption. Okay, in physisorption it arises because of van der Waals forces, and chemisorption it is caused by chemical bond formation. In physisorption it is not specific in nature, but in the chemisorption it is highly specific in nature. For physisorption it is reversible in nature, but for chemisorption it is irreversible. In physisorption it depends on the nature of the gas. More easily liquefiable gases are adsorbed readily. But in chemisorption it also depends on the nature of the gas, and gases which can react with the adsorbent show the chemisorption. And for physisorption, enthalpy of adsorption is low. It may be 20 to 40 kilojoule per mole. And for chemisorption, enthalpy of adsorption is high. It will be 82 to 40 kilojoule per mole. For physisorption, low temperature is favorable for the adsorption because it decreases with the increase of temperature. But for chemisorption, high temperature is favorable for adsorption and it increases with the increase of temperature. For physisorption, no appreciable activation energy is needed, but for chemisorption, high activation energy is sometimes needed. For physisorption, it depends on the surface area. It increases with an increase of surface area. But for chemisorption, it also depends on the surface area. It too increases with an increase of surface area. Okay. In physisorption, it results into multimolecular layers on adsorbent surface under high pressure. But in chemisorption, it results into unimolecular layers. Okay. Now look at the graph of adsorption isotherm. Okay, student, adsorption isotherm when extent of adsorption, that is x by m, is plotted against pressure at a constant temperature curve, thus obtained is known as adsorption isotherm. So when extent of adsorption, that is x by m, is plotted against pressure at a constant temperature, curve thus obtained is known as adsorption isotherm. Now student, look at the adsorption isotherms that are in your graph here. Values are at 273 Kelvin, 244 Kelvin, 195 Kelvin. Okay. X by m means where x is the amount of adsorbed bit and m is the mass of adsorbent. Okay. Now, Freundlich adsorption isotherm. Student, Freundlich adsorption isotherm, it gives the relationship between the magnitude of adsorption, that is x by m, and pressure at a constant temperature. Okay, and it can be expressed as x by m equal to k into p to the power 1 by n, where n of course will be greater than 1, and where x is the amount of gas adsorbed by m grams of adsorbent at a pressure P. Okay. Now student, we taking the logarithm on both sides of the equation, then we get log x by m equal to log k plus 1 by n into log of p. Okay, and then we plot the values. Look at the graph, x log of x by m versus log p. Okay, and we get a straight line. The slope of the straight line gives the value of 1 by n and intercept is log k. Okay, and this isotherm explain the behavior of adsorption approximately, and 1 by n can have any value between 0 to 1. When 1 by n equal to 0, then x by m equal to k, which shows that adsorption is independent of pressure. When 1 by n equal to 1, then x by m equal to kp, and x by m proportional to p. Adsorption varies directly as pressure. Okay, so both the above observation have been verified. Okay, and experimental isotherm always seems to approach saturation at high pressure, and it cannot be explained by the Freundlich adsorption isotherm. So, Freundlich adsorption isotherm fails at the high pressure. Okay. Now, application of adsorption. There are so many applications. Gas masks, activated charcoal or mixture of adsorbent is used in the gas masks, so that all toxic gases are preferably adsorbed and the air for breathing is purified. Then production of high vacuum. The remaining traces of air can be adsorbed by the activated charcoal from a vessel evacuated by a vacuum pump to give high vacuum. Heterogeneous catalysis. Adsorption of reactants on the solid surface of the catalyst increases the rate of reaction. For example, use of finely divided iron in the manufacture of ammonia and finely divided nickel in the hydrogenation of vegetable oil. Okay, then removal of coloring matter from solutions. Animal charcoal removes the color of colors of solutions by absorbing colored impurities. Okay, control of humidity. Silica and aluminium gels are used as adsorbents for removing moisture and controlling humidity. In curing disease, a number of drugs are used to kill the germs by getting adsorbed on them. Adsorption indicators. Surface of certain precipitates such as silver halides have the property of adsorbing some dyes like eosine, fluorescein, etc. In precipitation titration, the indicator is adsorbed at the end point, producing a characteristic color on the precipitate. Chromatographic analysis, it is also used. So in chromatographic analysis, it is based on the phenomena of adsorption and finds a number of applications in analytical and industrial fields. Adsorption used in separation of inert gases. A mixture of noble gases can be separated by the adsorption on coconut charcoal at different temperatures, and this is due to the difference in degrees of the adsorption of gases by charcoal. Okay, so these are the important applications of adsorption. Now adsorption from the solution. Freundlich adsorption, isotherm between X by M, that is mass of solute adsorbed per gram of the adsorbent, and the equilibrium concentration C is given by the expression, that is X by M equal to K into C to the power 1 by N. If we take log in both sides, that is log X by M equal to 1 by N log C plus log K. If we plot log X by M versus log C, then we get also a straight line. Okay. Now we discuss about catalyst. Student, catalyst. A catalyst is a substance which influences the speed of a chemical reaction without itself undergoing any chemical change. At the end of the reaction, the phenomena is known as the catalysis. So, a catalyst is a substance which influences the speed of a chemical reaction without itself undergoing any chemical change at the end of the reaction. And this phenomena is known as the catalysis. Catalysis is two types, heterogeneous catalysis and homogeneous catalysis.